Sketching graphs of rational functions. The first thing you do is you look at your function, and you ask yourself if it factors easily. If it does, solving by factoring is the simplest way. I notice that the top here is a perfect square trinomial, so this factors into y is equal to x plus 3, and the denominator is x plus 3. That tells me I have a removable discontinuity. I have the same thing at the top and the bottom. Set x plus 3 equal to 0, and we've realized that we have a removable discontinuity at x equals negative 3. After removing that, my function now looks simply like y equals x plus 3. I recognize that. It looks like slope-intercept form, y equals mx plus b. So I have a y-intercept at 3 and a slope of 1. There is no vertical asymptote. Well, when I begin with the idea of plotting my line, I know that I would start with my y-intercept of 3 and either go up 1 over 1, up 1 over 1, up 1 over 1 to the right, or down 1 to the left, down 1 to the left, down 1 to the left, so that I could create the path for my line. But I have a removable discontinuity at x equals negative 3. That means that that point right there can't really exist. So I represent that with a hole, which is why a removable discontinuity is also called a hole. My final sketch of my graph would look something like this. Let's sketch the graph of another rational function. This one does not factor, so I could use long division, and when I use long division, the only thing that's new is the invisible 0 that is in front of my fractional remainder. Well, there's nothing for me to remove from the numerator and the denominator, so there's no removable discontinuity. The remaining denominator value needs to be set equal to 1, and that tells me that I have a vertical asymptote at x is equal to positive 1. When I ignore the remainder, I'm given the equation of my line for my horizontal asymptote. So again, there's no removable discontinuity. The vertical asymptote is at x equals 1. The horizontal asymptote is at y equals 0. Lastly, the k value, the numerator, it's positive. Do you remember where that tells you that your branches live? Let's look. Here's my coordinate axes. I use dotted lines to draw in my vertical asymptote at x equals positive 1 here. My horizontal asymptote at y equals 0, that's the axis. And lastly, because I have a positive k, remember, it's like having a positive diagonal line. The branches will live here and here. So the final graph will look something like this. Here's another example of graphing. Let's say we've already done our long division, and this is what we ended up with. What do you see? There was not a removable discontinuity. This will help me find my vertical asymptote. Set this part equal to 0, add 4 to both sides, so x equals 4 is my vertical asymptote. Ignore this part. I have a horizontal asymptote at y equals 2, but this time my k value is negative. No removable discontinuity. Vertical asymptote x equals 4. Horizontal asymptote y equals 2. The k value is negative. Have my set of axes. I'm going to start counting out to put in my asymptotes. Again, x equals 4, the vertical line. Y equals 2, the invisible horizontal line. K is negative. A negative slope would look like this. My two branches will live in these two corners of my invisible asymptotes. My final sketch will look something like this. Last example. Again, we've already done the long division, and this was our final answer. Y equals 2x plus 1 minus the remainder of 1 over x plus 3. There was no removable discontinuity. This piece right here helps me find the vertical asymptote. Set x plus 3 equal to 0, and you get that x is equal to negative 3 for the equation of the vertical asymptote. Ignore the remainder. This time, I don't just have a number. I have an X. This tells me I no longer have a horizontal asymptote. I have what's called either an oblique asymptote or a slant asymptote, because it'll be drawn as a diagonal line. Again, you should be recognizing y equals mx plus b. So, no removable discontinuity, the vertical asymptote at x equals -3, an oblique asymptote at y equals 2x plus 1, and my k value is negative. Start with coordinate axes. Sketch in your asymptotes. 2x plus 1, go up 1, then up 2 over 1. To get a third point, I went down 2 and back 1. It keeps my positive slope. Draw it again as a dotted line. X equals -3, back up 3, draw in the dotted line. Last thing to ask myself, k is negative. Remember, negative makes you think of a negative slope. So I'm going to be drawing in the two larger sections this time. My final graph will look something like that.